Now we are going to talk about few tricks to learn Fleming's left hand rule and right hand rule. So children, I remember in my student life, I used to make my own tricks. I remember to learn periodic table, like I used to make a song, I used to make like it was Saktiv Karna, Manfi Ku, Nikozan and all that. I mean the short abbreviations I used to, and I used to make it musical and I used to learn it. Right? So same way for Fleming's left hand rule and right hand rule, I made a trick to learn, right? But the only thing is, to learn left hand rule, we will be actually using right hand, fine? But it's very easy to then make out in which direction force is going to act, fine? So let's try, let's see if you are able to learn from my tricks, okay? So here if you see, I have drawn few diagrams where I have indicated the direction of current and field. Fine? Field, I mean to say magnetic field. Fine? So from this, now we have to judge in which direction force is going to act. I mean to say in which direction motion of conductor is going to be there. Fine? So for that, you have to use your right hand as I told you. And you have to place your right hand in such a way that the fingers, they point towards the direction of current. Right? Like here. The fingers are pointing towards the direction of current, and then I have to curl my fingers towards the field, and then this thumb is going to point towards the direction of motion of conductor, or I can say it indicates the direction of force, right? Like here if you see, the force is acting towards the screen of my mobile right now, fine? So we can work on other cases as well, right? But first of all, let me write down here, force is acting towards the screen. Fine. Okay, now see here in the second case, I can write here force. In the second case, again, it is you have to again put your fingers such that they give you the direction of the current, right? And now I have to encircle my fingers towards the field. So if you see here now, the force is acting inwards. It is acting towards the board, right? So here the force is acting this way. Fine. Now again we have another two cases. If you see here, the current is acting towards the screen. Fine. It is acting towards the screen and the magnetic field is placed perpendicular to it. Again, as I told you, you have to keep your fingers such that they point towards the direction of field. Right? And now you have to encircle towards the field, and if you check out, the thumb is pointing towards left hand side. Again, I tell you, the current is pointing towards the screen. I have to encircle towards the finger and it is pointing towards left hand side, right? So here force is acting towards left hand side. Let's talk about this. Another case. Again, current is there and magnetic field is there. We have to see in which direction the conductor is going to move or motion of conductor is there. As I told you, current is pointing inwards. You need to curl your fingers towards the field. It is moving towards right hand side. So this way I think it's very easy to make out in which direction force is going to act. And suppose you have to have your left hand rule, so it sometimes becomes very very complicated in which direction it's going to act. Yes, I mean it's fine if you're able to make it out, but yes, sometimes it seems to be a big confusion. So I find it easy. I'm sharing it with you. Rest is up to you whether you want to apply this trick or you don't want to. It's up to you. Now the same trick can be applied for Fleming's right hand rule as well. Okay, so let us assume that the field is acting in this direction, right? Field in this direction, and motion of conductor is in this direction, or I can say from screen towards board, right? So this is your motion of the conductor, right? So if it is going to be this, now what we are able to find from right hand rule, Fleming's right hand rule, we are able to find out the direction of induced current. So let us see how it's going to work. Again, the motion, the fingers are going to point towards the motion, curls towards the field, and thumb is going to give you the direction of induced current. So I hope so you have understood how can this be applied. Such type of tricks can be applied to learn the complicated things. Okay, so it's going to be, as I told you, motion towards field, and it's going to point outward, right? So this is going to be the direction of induced current. So with this we finishes with this video, and I hope so you must have learned few tricks and you must have enjoyed the experiments done in this video, and hope so these experiments are going to help you to make your concepts clear. So take care. God bless you all.